Well, I guess we have quite a nice number of participants today. I would say let's give it a start. Once again, welcome from my side and hello everybody. Good afternoon, maybe good morning to the US. I'm very glad representing the NanoCommons project and the Nano Safety Cluster Working Group A on Education, Training and Communication to welcome you to this training event on the NanoCommons knowledge base. We are going to hear today from Dieter Maier from the Biomax, but also from Thomas Exner from 9 and Lee Walker from the UK CEH, and also a little bit from my side, from PLUS, University of Salzburg, on the versatilities and applications, different applications for NanoCommons knowledge base. We are going to see in the beginning, getting some introduction on the knowledge base and how to retrieve data from there, look into data completeness and the upload capacities and capabilities of the knowledge base. And then we are working ourselves through some applications that were there. And there was already a very big application, which was the NanoPhase project. And we are going to hear from Lee how they were using NanoCommons knowledge base and then see also hands-on how data were uploaded there. We are also going to look into the in silico in vitro workflow integration by this knowledge base, looking into a workflow that incorporates protein corona modeling. So this is one of our case studies. And then we hear about the instance maps, which were also used in NanoPhase project, and how to incorporate that into the things. I guess it's going to be a hopefully very interactive afternoon or morning for us. And please interact with us. We are going to have at the rather later than some breakout rooms where we can go even further into detail, although already in the plenary session, we are also planning some really interactive hands-on activations. And you're invited to use the chat box. We are always trying to monitor what is going on in the chat box, ask questions at any time. We are trying to refer to them as soon as possible, or just speak up and express yourself orally when you have any kind of question. This is really important to us that we keep track with everything that goes on in your minds regarding our knowledge base. I would also like to emphasize at this moment that you find more information about this and other contents. There is a complete series of also training materials, but also other contents on our user guidance handbook on the webpage. You see here the link. A short notice on the training next week, 2 afternoons full of nano safety and semantic web, so semantic annotation, run by the team from Egon Willighagen at the Maastricht University. I guess you should have also got an invitation for that already. Registration is open. There are further trainings planned in January by Tassos Papadiamantis from the University of Birmingham on the integration of electronic laboratory notebooks and how they cooperate then also with the knowledge base. The first one is a demo on the new features that are powered by NanoCommons project, and the second one is getting more into hands-on activities. And we are having regular Friday meetings with Thomas. Thomas is going to refer to that later on. Please leave us your email address if you want to come to these trainings and co-create with us different instance maps for different project types that you could then automatically start linking into the knowledge base as a kind of knowledge hub in between all these different types of projects that are using this kind of technology. This is exactly what NanoCommons tries to achieve. And here I'm arriving finally, or not finally, but for the start, finally, with some links, useful links to our communities or then channels at YouTube, for example, or at Zenodo. And also at Elixir Test, you find more information on what we have been achieving so far. If you have more interest, join the Working Group A. You get updates on that and further trainings. And of course, guidance, user guidance handbook link is shown here once again, and teaching materials accessible via the infrastructure of our project. Thank you for joining today. Over to Dieter for the introduction into the knowledge base now.
Yeah, thank you, Martin, for the introduction. And thanks everyone for joining. I think that's hopefully gonna give you a good idea about the NanoCommons infrastructure or part of the infrastructure, the NanoCommons knowledge base. NanoCommons is about providing infrastructure on a European level for nanoinformatics. And one building block is the knowledge base. And I'll give a very brief theoretical introduction because the knowledge base is sort of a mixture of different tools, and that's not always very easy to maybe distinguish. At first, however, I ask you, as we try to do a workshop today, really working on things together, if you have not yet registered, please register to the NanoCommons knowledge base. The link is HTTPS SSL BioMXD NanoCommons, and on the login page, there's a friendly question whether you have an account yet, and if not, just click on the register. It takes about 30 seconds, and you should receive an email with an activation link. Okay, that would be really helpful today because we want to do this as interactive as possible. So what's the concept of the NanoCommons knowledge base? The idea is to provide an interoperability and integration hub that technically allows us to link existing information in different ways. And the existing information that can be existing databases, data warehouses that have been produced in some projects already. That can also be raw data or data that has been produced in a project or by any group who's looking for a way of storing and managing that kind of information. So we have a mixed infrastructure here, providing a data warehouse to store information, but also providing a federation system to connect existing systems, not to replace them, but really to bring them together. Then make this information available in a user interface to retrieve information, to analyze data, to upload, and also to map to ontologies, which means we are also integrating further applications and tools here, especially for data analyzing. And we can go into some examples here. An important aspect of this kind of multiple activity is that we use something called semantic modeling to bring together all that disparate information. So what we do is basically we assume some basic concepts like a nanomaterial or a batch or a protein interacting with a nanomaterial and how they are associated with each other. And those basic assumptions allow us to integrate information. So we are not using the knowledge base as an archive storing individual data sets. We use it really for semantic interoperation and integration to make the data sets, to connect them and enrich them by each other. Okay. So the main features for today and the examples we're going to show is using the NanoCommons knowledge base as a data warehouse, storing your data that needs to be sustained long-term, or federating information, providing a catalog of information that's out there from all the different nanotoxicology projects that have been active. We don't have yet federated all of them, but that's an opportunity here. The second part is, keep in mind, please, that in this case, multiple data sets are unified using the nanomaterial as a central entity of mapping. And then on top of a single nanomaterial, you can have physchem characterization, you can have toxicology data, computational model information, and so on. So it's really going across different data sets. And the third part is that we have different types of data, physchem, ecotoxicology, omics data, and so on. So that's the different horizons that we're going to look into today. And with that, basically, just to reference the groups and the projects that contributed data that's currently available in the NanoCommons knowledge base. Those are NanoMaier, NanoPhase that we're going to hear today in detail, Smart Nanotalks, and the two infrastructure and nanoinformatics projects, NanoCommons and NanoSolve IT, that basically enable this infrastructure. Okay. And with that, I'll stop the presentation here and would like to go directly into the NanoCommons knowledge base and start showing you around on how to use it and how to go about the different types of information that are in there. Okay. So hopefully you already, all of you, arrived at the login page. Yeah, I can't type and talk at the same time. So this is your registration link that gives you your input access data, and that's your first entry page that you end up. And as you can see, we split the whole interface into 4 different parts. On data access, we're going to spend most time on this today. Data analysis tools, we're going to look into 2 examples, and then upload of data and ontologies. And ontologies in this case are a tool to make sure that if you upload data, it can be found again, it can be reused, and it can be connected to other information. Okay, but let's start with the data access with the first panel. As you can see here, we have distributed the information in different ways. You can access by particle, by characterization, by toxicity data, and so on. So if we start first with the particles, and let's go for all the particles. We are now on the data warehouse section here. And as you can see, we currently have about 600 particles or nanomaterials in the system. And I'll spend a few minutes here on this first page because the structure is going to repeat itself on every basically result page here. So what you get on the top of the result page usually is the number of results. If you go for a list, if you execute a query, you can actually select how much information you want to see on one page, and you can see how many pages there are. Then you have a set of columns with information, and then you have the ability to filter across those columns. Okay. Show and hide here gives you the chance to activate or inactivate columns. So you might want to see additional information like the Ninchi, and sort by allows you to sort the information according to a specific column in ascending or descending way. Okay. Going through the columns, the information that we try to request from everyone storing data in the system, and we are not curating from our side, we are making this available for the data providers to upload the data. But we are providing unique identifiers for each new nanomaterial that's registered. We try to ask for a license and for a reference to site. So license meaning what are the conditions to use the data that's being provided? Can everyone use it freely, or are there restrictions on how to share it, how to mix it. Then we have chemical elements associated with the nanomaterials, and we have the information about, for example, characterization data, that's FISCAM characterization, which kind of samples have been provided, aliquots, and so on. And usually I'm, for example, not very interested initially in the samples and in the aliquots. So that's what my entry page usually looks like to go through the system. So how can you work with this information? As I said, you can filter these results here. So let's assume you're looking for some information like chemical elements. You're looking for materials that are selenium and maybe also zirconate. And then you can apply the filter. And as you nicely see, there are none, because what you have to do is you really have to select the column you want to filter in for each of those criteria. And then you can see you have 15 results here, 15 materials that contain zirconium and selenium. Why are we using these kind of chemical elements? At the standard, we have it in the description. You could argue there is no need to use that. And of course, you could also search in the description instead. So let's get rid of this. Let's search in the all names, and then let's search for, and that's what's happening, because in the description, we have full text. So you really have to match the string, and in this case, you have a dash in between to be able to find. So that's the advantage of using the chemical elements and later on of using ontologies. Okay. So one issue you might have noted is that we have a Ninchi here. That's a proposal to provide, in addition, an extension to the Inchi key, specifically to nanomaterials, to be able to describe additional information. It's an early version. It's not yet what it's going to be very likely in the end. And there's not a lot of particles or nanomaterials that have already assigned such an Inchi. So this is really something to test, to play around. But as you can see, it's only 9 out of the 600 that have such an identifier. So this is something we really highly interested to use more strongly than that. What's missing now from this first page and from the information or from the actions that you can do is 3 things up here. Something that's called collect, export, and actions. You always have checkboxes on these pages. You can use the checkbox for all items and then deselect individually, or you can select individually. And you can then put these items into a collection if you want to build up a selection of items that you want to reuse later on. Or you can export them. You can export the information you see here as an Excel or tab delimited. Or you can go for different actions, and those actions can differ depending on what you're looking here. So in this case, we're looking at nanomaterials. And here we have FISCAM data or toxicology data that's going to be searched for and going to be displayed. So the FISCAM characterizations associated with those nanoparticles. In this case, we have not been filtering for nanomaterials that have associated data. So what could happen is that you find some materials have no data associated yet, and they won't turn up in this page. So now we are on a different page. Also, it looks very similar. As you can see, it's structured the same way. But now here we have information about the physical chemical property. Different nanomaterials have very different information associated. That's why you have a lot of here empty spaces in the overview. And you may also notice there is a plus button in front of the row now. That's because the information has too many columns. It cannot be displayed. And therefore the columns are hidden. But you can browse through them. They're gonna be exported if you export this information, and they are available for searching, even if they are hidden behind this plus button. Okay. So that's basically the information that you can search for and that you can then retrieve. And from what we try to keep in the NanoCommons knowledge base in the user interface is that you can go from every point to every other point. So here we are now at the PhysChem data, but if you are actually interested in toxicology data for those nanomaterials, you can run the same action here, and then you get a set of toxicology measurements that have been done for those materials. Okay. Structures the same as usual. Columns are hidden. In this case, there is additional information, not only measurements, but also about the aliquot, about the nanoparticle or nanomaterial, and about the type of measured information. Okay. So if we look into any of the measurements, there are additional information, and I have to check. Okay, let's see. I have to do that differently. I can't switch tabs here. So for any of the measurements, we have additional short descriptions and information on individual reports. And you can, again, take turns in going through the system. So now we are on the toxicology measurement. We have some information on how that's been measured, when experiment information. We have here the information about the aliquot, and that's something we're going to come back in much more detail in the section about the nanophase data. For navigating in the system, you can always go back to the home, and you can basically restart here, or you can navigate in the sidebar into a specific section, an overview page. You get then all the options for that section, or you can go through there in the sidebar. So we started with the particles, just as a quick reminder here. We have sections on characterizations that basically gives you the full list of available characterizations, 4,100 for those 600 different nanomaterials. And similar to the information about the toxicology experiment, you also have information here about the nanomaterial characterization. In that case, we also have a bit more options right now. We have options for you to upload additional protocol files or raw data files. That's something that's not yet been needed for the toxicology, but it could be added quite easily if that's a requirement, for example. So I'm not going, I think, through all the individual sets, but let's go for one more for parameters, because that's also information we need later on. So as you can see here, we have 452 different parameters measured for any of those nanomaterials. So one parameter can be measured for at least one or for many nanomaterials. And here we list them all, regardless whether they are from toxicology, whether they are from FISCAM characterization, or maybe even computational modeled. What we try to do is, and that's an important part also later on, to connect each of those parameters to an appropriate ontology entry so that you can really search using ontologies and that you have a clear definition of what this parameter is about. Okay, so that means, of course, also that you can search using ontology terms for those different parameters. You can even browse the ontologies and get all the parameters associated with some section of the ontology. Not here, different place. Okay. So that would be a first step into the system. And what I would like you to do is maybe spend 2 minutes on finding materials for Titan dioxide and try getting yourself an overview what's there and getting some experience so that we can discuss issues and questions later in the breakout session. So I'll do a very brief break here, give you some chance to try and execute some of the queries yourself that you just have seen and note down some of the questions you're coming across. And then I'll go into the next part, which would be about how can you get an understanding of how complete data for given nanomaterial is for some given use case, like calculating a NINSHI or doing a QSAR model. Okay. So I'll give you a few seconds here. I'll not continue showing things, so you can really jump around and try things yourself. And then I'll come back.
We meanwhile got 2 questions in the chat. And the first one, I can read it for you, Dieter, is can we export ecotox data and at the same time the FISCAM data for a nanoform?
You can export both types of data, not at the same time. So what you would do is you would first do a, let's say, FISCAM export. Each export has the identifier, the unique identifier of the nanomaterial that it's associated with. And you could then export the ecotext data separately because it's separate format, but you can bring it together for any application based on the unique identifier. And I think it goes on the question with even coming from different databases. So I'll come to that again later on. So coming from different projects, yes, we have if we use the NanoCommons knowledge base as a data warehouse, then the data from different projects is integrated really on the level of the nanomaterial. If we federate to an existing other database, like let's say the NanoRec2, then what we agreed with the groups providing those resources is that we use the NanoCommons knowledge base as a catalog, so on the metadata level. So you can search for nanomaterials there. You can also search for available information. So is there FISCAM characterization? Is there toxicology data? But then for the actual data retrieval, you have to jump into the corresponding data warehouse that has the original data. So in this case, we are not mixing, we are not copying, we don't have issues with synchronization, because if something changes in the external database, then if we copy, we would have to recopy, and we're leaving all of that out and keep it on the search level. Okay, so that's gave you maybe a chance to play around a little bit. And with that, I would then go into the next section, which is about data completeness, basically, and how to upload data. So data completeness is something that we view as a sort of an analysis, a very simple one in a way. And the idea behind it is that it gives you an indication for a number of use cases of how complete the data currently available actually is to execute that use case. As this information is data-based, it's also giving you this indication only for those information directly warehoused. But you could then go and search for external, in the external catalog, whether there is more information available. So what you see here graphically is for each of the nanomaterials, we indicate for different use cases like grouping and read across, or nanoform identification, or NinChi, and we have a couple more like regulatory, prediction, how much information there is for a set of required endpoints. And the set of required endpoints comes from a couple of literature reviews done by Gracious, done for the ToxR tool and for the NinChi identifier, as well as expertise from the NanoSolvit partners on what's required by OECD, by ECHA, and so on for the corresponding action. Okay, and if you're interested what is required, here you can go to the list of required endpoints. For example, look for grouping read across, and then you can search for which information is necessary to do a grouping. Okay, and in this case, it would be the area, crystallinity, shape, and so on. There's a new feature here I haven't explained yet. I'm just realizing on some of the pages that you do an interactive search, that you have some input. You can later on modify that search and look for the information or look for new information without having to go back. So as you can see, if you want to calculate a NinChi identifier, you need information about not only size and shape and crystallinity, but also functionalization, components, and coating, because the NinChi is giving you more information about the overall structure. Okay, so going back here, what this table then tells you is that, for example, from the 8 required variables or parameters measured to be able to calculate a grouping or a read across, there is one measured and available currently in the system, or for the 4 for nanoform identification, it's 1, and so on. So as you can see, there is some information here, but for many of the materials, it's not yet all the information required to do the corresponding calculations. And that's especially true very often for example, negative information. So like functionalization, if it's not given, we are right now not assuming that there is no functionalization. We are right now assuming it's empty. Very often that actually means there is none. And therefore, this would be actually much more complete than it looks like here. Okay. So this completeness information is also, I want to show that before showing the upload information, how to upload data, because it explains a little bit why providing metadata and description for your data is so important, because it enables us to do calculations like these. Okay. So assuming that you find what's collected here useful and that actually you wanted to contribute something you have calculated or measured yourself, calculated in an experiment, in a computational calculation or experiment. What's needed for the upload is that we have a unique identified nanomaterial, either already in the system and you have seen how to look for them. If it's not yet in the system, you would please have to upload the nanomaterials first before uploading any experimental data or any description of the parameters that have been measured. So let's start with the upload. We have a very similar interface here for every step. So basically, what we provide is an Excel template if you have multiple entries. If you have like just one new material, then you can just create it manually, maybe. But let's assume you have a whole list of materials. Then you would actually download the template. You would then fill that in. And let's open that one. I think I did something. I have to change my, sorry, you can't see, I guess. Sorry, let me stop for a second. Yeah, okay. So now you should be able to see my Excel. So basically what we need as a required information is orange in the template. Optional information is green. As you can see, if you upload a new nanomaterial, the only really required information are the chemical elements that contribute to that material. Of course, a name and a description will be very useful, but strictly it's not required. But as you can see, the data becomes rather useless if this information is not provided. So that would, of course, be great to add that kind of information. And once you have filled in the Excel, then you basically upload it again. And what the system does automatically is it's going to check for the required information, whether it's there. It's going to check for the syntax, and it's then going to add new materials and provide identifiers for those new materials. Okay. Once that has been executed, you would have to use those new identifiers that have been provided, the unique identifiers, because there may be 100 materials of titanium dioxide. So let's go to the next step, upload parameters. Parameters, as I have shown, are basically the measured or computed parameters that you want to add to the system. And of course, there is already a whole list. And please, before starting uploading new parameters, take a look into that list, search for anything you might be interested, let's say size, and see what's already there and see also how it's defined. Okay. This is a rudimentary search. I showed you there is a parameter search that allows you more filtering and more complex searches. And it also shows you already how many experiments there are associated with this kind of information. Okay. But let's assume you have been creating a new technology and you have new data that's not been measured before. Then of course you will have to add parameters. And again, there is an Excel template to download. And that Excel template contains the same basic structure. You have a couple of, sorry, to close that first. You have a couple of columns here. And in this case, 2 of them are required, a parameter name and a data type that this is associated with, whether it's text or float, numeric, categorical. You can add synonyms, you can add unit information, description, and an ontology term. And it would be great if you take a few minutes and look for ontology terms that are already existing. And you can do that in different ways. You can either browse the ontologies that we have in the system, because you may already know that there should be a term in the eNanoMapper ontology. And then you go for, I don't know, searching for size. And you can see that there is, for example, a size endpoint here, which may be the ontology term that you're looking for. Okay. Or you can go for the browse ontologies, which basically brings you to the same page. It adds one option for searching here, and then you're on the same side here. Okay. So that's the parameters. And once you have done that, finally you can upload your data. You have to pre-select whether it's particle characterization or toxicity data. If you have other information, please contact us. Those are the standard things we came across and that are enabled basically automatically. But we can store basically any kind of information, but we may have to come up with a new import or a new mapping for new information. So please contact us. We're very happy to help and support. So let's look into that template as a final part. And let's just call it different. So again, quite simple, quite straightforward. We have a nanoparticle ID, and that's really the unique identifier of the nanomaterial that you have created previously. We have a parameter ID that's coming there, and then we have a value. And that's the very simple way of uploading information. And that's the minimum requirement. As I said, it would be helpful to have protocols and so on, but that's not strictly required. So you can start by just adding some values here. Okay, that's basically what I wanted to show in this section very briefly. And again, I would ask you to do a little task so that we have some things to discuss for the breakout. And in this case, please search for parameters that you are usually measuring or looking for, and check whether they are in the system already and where they are and maybe how much information there's associated. And I'll briefly switch on my light, so I'll be back in a second. So the next section, just as an introduction, will then be about the nanophase data. I'll then hand over to Lee for a few minutes, who will explain the background. But as I said, we'll give you a few seconds to try and find your way around the parameters and what you find there.
We had some questions. Meanwhile, I guess we can come back to some of them, maybe even in the breakout session later on. One might fit, or one we might address immediately. I mean, SOPs were requested. I guess we can also show a little bit on that during nanophase, or also during our protein corona case, right?
Yes, we're gonna come to the SOPs, how they can be linked to the different, basically they are linked as a protocol to measurements, and we're gonna show that as you mentioned, if in two different ways to do that in the two use cases.
And then there was one question regarding, you mentioned it earlier with the completeness discussion on regulatory completeness. What is implied by this term? Are there some specific criteria to evaluate it?
Yes, if you look into the list of endpoints there, what's stated for regulatory endpoints is, in this case, really size and zeta potential to characterize a nanoparticle. And as I said, those are requirements from different groups collected from, for example, ECHA to define a nanoform and so on. So it's not general regulatory, but it's specifically to characterize a nanoform here. Okay, I think that's given everyone enough time. And then, Lee, I'll hand over to you.
Thanks, Dieter. Hello, everyone. My name's Lee Walker. I was the project manager for the Nanophase project, and I'll just briefly introduce what it was and how NanoCommons helped the project and how we utilize the NanoCommons knowledge base. Okay, so, oops, sorry. So the Nanophase project was aimed at developing a framework and underlying models and methodologies for assessing the fate of nanoparticles in the environment and through the value chain as well. So on the left-hand side here of this schematic, you have the different stages of the value chain, moving through down to the bottom left to waste management, and then we were predicting movement of particles or release of particles from those processes into the environment, different environment compartments, so air, soil, water, and biota as well. And then we treated each of those compartments separately, and then they were combined in overarching spatial and temporal defined models. So as part of that work, there was a lot of empirical data produced, both for the value chain, waste management, and environmental cell reactors stages. And how we approached sort of the data handling and how we were going to share that data was to take the approach of that was developed as the NIC database in the US, and that was to look at the experiments in terms of instances. So these are time defined points in an experiment, and for each of those, or each of those instances, you define the media, the properties of the media which your nanoparticles are in, and the properties of that material as well. And when defining those properties, obviously you need methodologies, so protocols to do that, and you utilize instrumentation as well to carry out those protocols. So that can all be sort of supporting information that you have around those observations you have. And we use these instance maps, as this is an example, very simple example of, to generate the data templates which we use to capture the data we're producing. And so in this image here, you can see sort of what you think of as sort of data information. So this is defining for the instances sort of what you were measuring, so concentrations of silver, for example, the size and diameter of the particles in the stock, dispersion, things like that. But what I'll do is I'll draw your attention to the tabs at the bottom. So you've got your data, but you've also got all that sort of metadata that help you to interpret the results that you have. So down to sort of the person in the institute that produced it, what papers were publications were associated with that data, but also sort of the instance it relates to, the protocols that were used to measure those endpoints and the instrumentation as well that was used. So all of this was captured in the data templates, which then uploaded into the NanoCommons knowledge base, and Dieter will now run you through what that looks like in the knowledge base. Thanks.
Thank you. Yes, I'll start sharing again. Okay, there was one question in the chat that I'd like to go into before jumping into Nanophase, because I actually forgot to show it. There was a question whether you can search across many columns at once. You can, in a way. Up here, there's a general search, and here you can, for example, search for something like an identifier, or for, let's say, a name. And this general search, it's not exactly searching across all the columns, it's searching across everything in the system. And it then lets you filter down by these different ways. So you can filter down by instance or nanoparticle or sample, or you can filter down by different types and so on. Most of the time, what we find in the result set is, for example, different nanoparticles or nanomaterials, and then you could check where your match is, basically, whether it's, for example, here in the name or in the description and so on. So it's not quite searching across all the columns, but it's basically searching across everything. Okay. But with that, back to our Nanophase. And as you have seen, it's a bit, the data is structured a bit more complex, and that's one of the cases where we don't have this represented on the upload page, but rather developed a dedicated upload, because we thought that's quite unique, and it's more complex than most of the uploads will be. So it's not yet available, but we are happy to learn better. And if you have ecotox data of this type, then we are very happy to help you upload or make the upload available. Okay, so Nanophase has been recently released, October. And what we have maybe quite interesting in this case is a summary statistics by all the different parameters that have been measured. So this is an overview of all the information for each of the parameters measured. So in this case, diameter, what are the different diameters in the system, or purity, what's the average purity. So that's maybe, if you're new to Nanophase, a nice way of starting and going there. But if you are basically looking for data, probably a nice place to start are the different data sets. So the data sets really are from the different groups involved in Nanophase, the kind of different designs and measurements they did. For example, if you go here for the lighthead, we have carbon nanotubes that are released from weathering polymer, and that then, or recycling of that polymer, polypropylene, and then measurements for those. So that's something, if you want to understand what's going on, you could go into that data set. You could see a bit more of the description and which parameters have been measured, and also what kind of information there is. Okay. Going back there, if you want to access information, then you probably you need to go deeper. It's not on the level of the data set, as we heard from Lee, it's actually on the level of the instances. So we had 33 data sets here in the system, but we have 445 instances. So these are the different, in a way, samples that have been used and that have been measured for. And as you can see, each of those instances is associated with a data set. So you could filter here, of course, for a given data set and all the instances. And then you have for each instance the associated information like time of measurement, since start of the experiment, since the last step of the experiment, and then the actual measured information here. So what we have in this list is different information depending on the individual measurements. So some have a restricted information, some have much more information. So here you have, for example, this leaching experiment where you really have a detailed protocol where you have the instruments associated with the protocol to prepare those samples. If you go for one of those instances, then I'm lost here. Sorry about that. Then you can add information there, and for each of the different protocols and measurements. So I need to, for example, go for a protocol remeasurement here. Can I? Okay. Okay. And then for each of those, you can also get the information about, for example, the instruments, which other data sets have been using it, or for the characterization, what other information there is for this given characterization. And here also, just to mention, two more options to upload information that are measurement specific. So if you have protocol files for a given measurement, they can be added here on the level of the individual measurement. And also if you have raw data, it can be added here to each of the measurements. Okay. Other information that we have, or other ways of accessing information, is the instruments and the protocols. So that gives you an overview about which instruments have been used in the system or during nanophase, and especially, as I already showed you, which data sets this instrument has been applied to. Okay, so you get information about where you have transmission electron microscopy here. And the same is for the protocols. We have currently 51 protocols here. So for each of the protocols, you can see which data sets that protocol has been applied. And you have individual steps of the protocol that describe in detail how that's been used, and then in which of the instances this protocol has been used. Okay. So compared to what we saw previously, this is a more complex data structure, and therefore, if you want to access the information, it's not on the characterization level or on the toxicology level. It's on this instance level, from where you can then go to the different measurement data. Okay. So that's the first use case, nanophase, that we wanted to look into. And before we have a short break and a survey and a question for you, there's one more issue that we wanted to look into. That's the external data warehouses, and that's using the NanoCase knowledge base as a catalog. And one example that we have currently available, that is the Mbit data warehouses. Mbit is hosting data from projects such as eNanoMapper or NanoRec 2. It's a database software that's available that can be used for data warehousing. And as mentioned, what we're doing here is on the fly connecting now to an Mbit instance, or in this case, to 3 Mbit instances that host eNanoMapper, NanoRec 2 data. And as more data becomes publicly available, this will extend. And the use cases we have implemented is that you can actually look for all the different nanomaterials that are available. And of course, here now we are depending on the descriptions and ontology links that are provided by Mbit. So that looks slightly different from what we have if we warehouse directly in the knowledge base. I think it's extremely helpful to gain an understanding which nanomaterials there are and what kind of data there is. So as you can see right now, there are 902 different materials in those coming from those different projects. You can again filter in the same way as we did in the other projects. You have to be aware that this filtering will take more time, because we are really posting the query now across the different warehouses hosted by Mbit, and we have to wait for the execution to come back to be able to pull together that kind of information. So that's of course another issue if thinking about federating, providing a catalog or copying data. If there's an issue with the performance overall, then that's something to consider. And sometimes that may be something you have to, in the end, provide a copy, even if that's maybe not the most desired result. But for Mbit, the access is okay, and the time, as you can see, there is a bit of a wait, but I would argue it's doable. So here you have 134 carbon associated materials of different types. And then for each of those substances, as I said, if you're really interested in the data, you would have to go to actually Mbit and then go into the database there and retrieve the information from that user interface here. So that's the option for the type of nanomaterial. We can also look for endpoints available in Mbit. So we can look for the full list of different endpoints that have been measured. We can look, for example, what kind of PhysChem endpoints have been made available. So you can see we have things like dustiness or boiling or so on, crystallizing phase. And we can then use those endpoints to check how many materials there are for each of the endpoints, and then to search specifically for a given endpoint there. Okay, and that allows us to go for specific nanomaterials. So we can look into searches, restricting the kind of materials we are interested by different sets of endpoints, for example. Right now, you have to select which set, but that's something we can change so that you search across all of them. That's a bit a question also on user feedback here. What's more convenient? What's the most used use case? And then as you see, we have here a set of nanomaterials with FISCAM characterization. So then you could go into the ambit for that given nanomaterial. Okay, so that's the catalog functions that we have available right now. We are continuously extending the systems that are available here. Right now, we're working on Sparkle endpoints to add individual data sets in the same sort of catalog function. And then that should be also work the same way. So you can search through the metadata, and for the actual data, you would go into the data sets. So with that, I'll stop here and hand over to Christine, because we'd like you to provide a bit of input and interaction here.
Okay, we're going to use menti.com, which some of you will have used before. I've just put a link in the chat, or you just go to menti.com. And I'm now going to share a word cloud with you. Okay, so what we'd like you to do is, like I say, you can either go on the computer you're on or on a device you've got. Go to menti.com, and the code is 16356501. And the question is, what do you use the retrieved data for? And you've got up to 3 things that you can type in, either single words or a couple of words. And they should start appearing on our screen very soon. And hosts and co-hosts, feel free to join in too. Anyone? Excellent. First start. And I'll maybe let Dieter comment as well as these come up, or anyone else who wants to comment on your thoughts.
I like the point where it was saying compare to your own results. This is definitely something of interest, and also maybe it kind of compared to the formats that you deposit in warehouses eventually. So what else do I want to report in regard to metadata? So I was, for example, also very interested in what these metadata templates were looking like.
Risk assessment, that's a bit bigger there. A few people have said that. Anyone else wanting to contribute? Be another minute or so. Still quite a few of you haven't been able to. Any other thoughts on that, Dieter, on what's going on?
Yeah, I think risk assessment is, I'm surprised by the strength. So that seems to receive multiple answers. And I think we need to then make sure what's the requirements for the data, if that's used for risk assessment actually.
Experimental design is also getting multiple hits, as it were.
What we also do see a little bit is somehow the cross-linking capacity eventually to modeling and to in silico evaluation, to provide data in a way that they can be read and be used for model builders. That's what we see here also, or I see, I would say. It comes up a bit stronger as I talk about it. And experimental design, yeah, keeps up on track.
Okay, excellent. I'm not sure if we're going to get any more. So that's great. We're going to use something similar in a little bit as well. For anyone who didn't get to Mentimeter this time, we will be using it again after the next talk. So thank you for contributing to that, though. I'll stop sharing my screen. And I'm now going to hand over to, I'm not sure who's starting this, but to Martin and Dieter, who are going to talk about corona modeling.
Yeah, we have heard quite a bit about how we deposit the data there, how we get access to the data, how we can retrieve the data. I would like to introduce and kind of take you on this little journey through a kind of experimental workflow that you see here on the screen now, where we were kind of trying to incorporate into a very typical experimental hazard determination workflow. Also shortcuts to tools that are available. And here we see, so there is basically a research question in the center of this slide, which you see. And this could be any kind of research question. We just were kind of interested in looking a little bit more into the molecular alterations that happen to proteins when they bound to surfaces, in this case, nanomaterial surfaces. And these were differently functionalized surfaces. So this was actually our research question. We tried to, which we see here in this data life cycle, also to draw a kind of a cycle where we ran through from the beginning of our project, where we were synthesizing ourselves and functionalizing the materials. And then at the very early stage, starting to kind of deposit them in the NanoCommons knowledge base. And we have just seen from Dieter how one does that. We have done it pretty similarly. We were not having hundreds of different materials, but just these 4 ones. So we did type them and create these nanomaterials there individually. And then we were looking, as we were also seeing in this word cloud earlier, for characterization templates. And I was very interested in what do they look like, to see what were other people kind of using. And we used these templates that were provided by Dieter from the NanoCommons knowledge base, and filled our data into these templates, and even then started to extend these data templates, because we thought, well, we would like to provide more information. Like if there is, for example, a size determination, it's not just size, it should be NTA measurement, and the NTA can give you a value in mode or in mean, for example. So we would like to give all this information into there, and we're providing more and more Excel formatted metadata sets. And we will see look into that a little bit later. So kind of provide this characterization. So upload all these more comprehensive sets in our view in this step. And then we went into 2 models which were offered in this analysis icon there. And I guess this is now the time point when we look into that. And the first one was the nano extract based TM image analysis. We have had a training on that about a year ago at the 23rd of November past year, in the NanoCommons, in the Nano Safety Cluster training day, and I will refer to this event. And there are a slide set available, and there is also some YouTube recording which you can look into. So we are not going to go into detail of that one, how this is operated. Just see how the link is there, and then also to the protein corona in silico modeling capacities of the NanoCommons kind of science hub in a way. Good. So for example, for creating, just very shortly, our nanomaterials, and this is just 2 representatives, we did then deposit these TM values and NTA values, DLS values, for example, for different ones, as you see here, and these values are there using the templates as we have seen them before. and being then also kind of supplemented by lots of metadata sets. So these type of Excel sheets we're going to see now in the database. And I have to say that I'm a user. I'm not as proficient as Dieter, of course, in using it. I don't do this every day, of course, and I just tell you once again. So this is the icon where we did the uploads of, we defined our particles, did look for the parameters, check out what is there already, and then eventually provided new ones with supplemented descriptions. And there at the experimental upload, actually where we put in our provided information. And then we, for example, by providing or defining this nanomaterial, typing in the elements, for example, we obtained our different NanoCommons nanomaterial identifier. So like, for example, this guy here. It was also supplemented by an Ninja code. And basically this was a very concise description of what it is. And so the first thing we did then also by going to analysis, like here, if you go to analysis, you have here, for example, image analysis. Yeah, and this is what we did, for example, and I'm not going to go into detail that, but we ran through this nano extract tool, providing actually having before also uploaded an image of our TEM images, so the electron micrographs, basically, and we were provided, and in the end, after also being optimizing the different parameters required for that, with different nano descriptors for these nanomaterials. And this is, for example, that modelers might be using for different toxicity assessments and hazard assessments later on. We were not going into further detail. However, we were able to enrich our data set, because normally what people are kind of providing in publications is, yeah, they look at the primary data, primary size, and they give this value of, I don't know, an average of 25 manually counted materials, an average primary size with a standard deviation. So we had a whole list in addition of different nano descriptors, which I was not aware of before. And I mean, they might provide some useful information for other instances. I use a lot, honestly, this overall search button up there to come back to my particle, by the way. So we talked about image analysis, and then we were providing lots of information regarding particle characterization at different pH values, because we were looking at different pH dependent protein binding parameters. And here we see the raw data template, the raw data, for example, are collected, and then we did also provide lots of additional information, like, for example, for the NTA measurements, just that you have a glimpse on how detailed this is. So all the different data and metadata are collected then also here of the different repeated runs that we did. Or for example, for DLS, there is also, of course, something to provide. This is not as comprehensive set of different, basically it shows all the different settings also for the instruments. So we pulled together a couple of repeats of these experiments into Excel formatted data compilations. Yeah, and basically now looking quickly back into what this project was about. It was about protein binding. So we had lots of protein interaction data in the end, and we looked at the in vitro side, how do they impact eventually then the folding of the molecules? Is there a way that we could assess the orientation of the molecules on the surface? And how about epitope display? In the end, some of these molecules were allergens, so we could use reporter systems that are very specific for epitopes that are eventually hidden or eventually exposed or accumulating due to some orientation around the surfaces. So we were then correlating these type of assays at the in vitro side with results derived from the in silico modeling going back to the hub. So then here, for example, under analysis, you can go to the corona analysis. And then this starts by the way that you start a new corona analysis by new analysis run. And then you add your particle. So I will then now, to be quicker, just use this guy here. Oopsla, sorry, I hit the wrong button. Repeat this quickly. So add one nanoparticle, you have to select one.
Box.
Tick the box. And add a protein. And I just tick a box now for whatever is offered quickly. And you see there is a quite long list. This is a list of almost 44,000 proteins that are there. So you can look for your protein, and then you also add some further information which you need for the input, because of course protein binding is dependent on a couple of things, like for example on the size and also on the zeta potential. And this is something that you are defining for your material, so you can give the values here. For example, there is the value being derived from a measurement like DLS or NTA, whatever you have, so or TEM, for example, then these 12 nanometers which you put there. And you also give the value minus 16.4 for the zeta potential. I guess I would have needed to use the dot, for example. So there is something not correct. The German keyboard. Check the data input. Okay, and if the input is okay, then you let it go. You can start the analysis, and then this will pop up. It takes a while at this particle, and you can check what this looks like. We're not going to wait this time. We just look at basically what we have obtained, and then I will give you a few explanations to what we saw there. So for example, if you go back to the one of our particles that we had there, and further below, we have lots of these binding assays, and we can look into some of these SOPs, for example, that were also deposited there, and metadata, metadata reports. And further down below, we have some of these analysis. So what you obtain is basically, so you see here once again the particle, you see here the protein that you used. You also have a link to the PDB file, so to the protein structure. And what you obtain is basically for this parameters that you have used, a heat map. So this heat map kind of expresses a psi and a theta angle of a rotation that is required for your protein as deposited in the PDB to be rotated in the way that you see the orientation, how it is coupled or conjugated, kind of adsorbed onto the nanoparticle surface. And we see this is not even. So there's obviously a kind of a hotspot in this area where we have to rotate our molecule by the psi angle of 300 and let's say 40 or 35 or something, and by the theta value of 85 or something like that. Yeah. What you can retrieve, you take this map, for example. So this is, you just hit here the map, and you can open this by any type of editor. And this is the map. And then you get all the values for the minimum energies. And of course, it must be a very minimal value, the minimum energy that is required, that there is no repulsion, that you would be able then to find. And this is the psi angle and the theta angle. And then you find here further below somewhere the area where you have the expressed value. By this, you can then also get a view on how affine your protein is for the nanoparticle surface. If I go back to this slideshow that I got here. So this is again now here, this map that we just retrieved from the database and the heat map here. And we see here at these two angles, there is obviously a minimum. And this minima you can then also collect in data, like in an Excel format or something, and you could then compare between different proteins. And this is, for example, what we did. And compared this then to lists of experimental results where we were also able to kind of see differences in the affinity of different proteins to these nanoparticle surfaces. You also obtain there, you might have seen it earlier, not just the map, but the log file. And this is basically retrieving all the metadata that was used for this protein corona modeling. And you see here that the PDB entry, for example, the particle. So this is all deposited there and sits together with this analysis. How do I interpret such kind of results? Using programs, for example, like PyMol or the UCSF Chimera, you can then rotate automatically the PDB entry that you have retrieved from the database by different angles. And if you used such a script, then you would see then in the end the epitope or the region of the molecule which is somehow facing yourself. And this is basically by using these angles that you obtain from the heat map, and then you look directly from the particle, as if you were the particle onto the epitope that is binding or has the highest affinity, I should say, to the nanoparticle surface. This shall not in all cases, of course, coincide with what you would result in having a kind of a developed, ready protein corona. But again, I mean, this is the molecular initiating event between the particle and the protein absorbing it to each other. Okay, so this is actually what I wanted to show regarding that, and I guess we can give more details because we're going to have some breakout room later on that. Dieter, shall I go, or would you like to go into some more detail regarding that? I also have not seen whether some questions popped up in the chat box.
There are no questions right now regarding this type of modeling interaction. And maybe we have more for the breakout rooms. We have two questions in the chat that were more generic that maybe we can go into before going into the next feedback session. And what I'd like to add is that why we show that today is that the NanoCommons knowledge base is really about interaction and about all kinds of data. So this is really computation heavy information that's also available in the system. So it doesn't have to be experimental. It can be computational predictions and so on. We believe those are quite as valuable, especially for comparing with experimental data and for improving our models. And we did not go into the smart nanotox data today, but that's computational descriptors calculated for several hundred theoretical nanomaterials, and you might be interested to look into. But maybe going into the two questions in the chat. One question was about how can you access toxicity data for a single given particle? And for that, I'll maybe share my screen. And show how that could be done. If you're interested in data for an individual particle, the easiest way is go for those particles that have any data associated, or go for any of the particles. It doesn't really matter. Filter for the particle ID, and then use the action button, for example, to get your toxicology data. That would be the fastest way. In a way, if you come from the toxicology data, then for each of the different types of measurement, zebrafish, A45549, and so on, we have here the list of particles that this kind of data is available for. And then you could go for that list and filter in here. So that's the two different ways of going about. And the other question in the chat that we had was, is the same search for endpoints as shown for the catalog, so for the embed, is that available for the nanophase data? And basically it is. We have the list of all the nanophase parameters measured, including summary statistics, and you basically can filter there and search there. That's the two questions I saw in the chat. And then before going into the different breakout rooms where we can discuss in detail about either nanophase data or the modeling, the interaction modeling, or the NanoCommons knowledge base in general, we would have another question for you and ask for your feedback, and I'd hand over to Christine for that one, please.
Okay, so back to Mentimeter, and I'll share the question with you. So the question is, which other information or tool would you need in the NanoCommons knowledge base? And again, go to Mentimeter, and the code this time is 3295-3275. So 3295-3275. And again, you've got 3 opportunities to put some suggestions in. Who's going to be first? Okay, any thoughts? People struggling, or maybe Dieter needs to put some in first to get the ball rolling. Is it working for people? Are people having a problem? Oh, no, it is working for someone.
That's a nice one. Yep. We definitely go about that one. Mm-hmm. Plotting of data, making graphically visible. Mm-hmm.
Anyone else want to have a go? You don't have to put 3 things in. It gives you 3 options. It's not like, and it's not a test, and we don't know who's saying what.
Perhaps I can inspire something.
But
Data quality checks. I don't know. This is a really tough thing, but if somebody has ideas how to bring that in, especially since you have these single data points. Let's see.
Getting a couple more ideas now.
And maybe what would be interesting also, as we had in the previous one, is experimental design algorithms, because that's something that's existing as a tool. And as we had many questions or many people using it for experimental design, that might be interesting as well. I guess. Oh, access by API there is. Thanks a lot. There's documentation, but it's too much for today. But if you're interested, I'll point you to the documentation.
Yeah, there's a few more coming up now. Any more thoughts on these, Dieter? I think we've slowed down.
Summary pages for nanomaterials, that's also a nice one. We'll extend that. There's a bit of information right now, but I can imagine what you mean by that is drawing it together from all the different knowledge bases. And that's an excellent idea, yeah.
Okay. Right, well, thank you very much, everyone. I'll stop sharing that again. Right, I'm going to hand over to Thomas now, and he's going to talk to us about instance maps, and then after Thomas has done his piece, we'll do some spend some time in breakout rooms. Over to you, Thomas.
I hope you can hear me now. Yeah, you see, we changed a little bit the time table and make that first, because then we have more or less all the presentations over, and then we can really start discussing as long as we want. Just a very quick overview of what these instance maps are actually, and why this is connected to the discussion today, or the training today. I give a little bit of a history. Did I know? No. History, where this is coming from, and this is, I think, Dee already mentioned the NICSI or NIC project, where they were really looking at curation of data from literature and trying to have a visual inspection or visual guide what these studies which were presented in this papers are actually looking or doing. And in that way they started to have these instances, and then which is a nanomaterial in one state, freshly prepared, or something which is then going through different transformations. And every of these instances can then have associated measurements or properties, or they are in a specific medium, and all these things are then described as part of this instance. Yeah, and in that way you can really show what the progress or the time evolution of this nanoparticle is during the experiment. This went on to the nanophase, where they then used that for the experiments, which Lee showed, yeah, where they had these different stages from exposure into the environment, and then they could look at different stages, and this is just another example from the nanophase, where you really see that they had different surroundings, and it's not really media, it's more environments, yeah, that you are in the soil or in the wheat, and then you go from 1 day exposure to 24 or even longer exposures, and each of them are easy or single instances, which helps to then structure the data also, yeah, that you come from this huge complex system of a lot of metadata for one template, to then be in this easier way to look at the data at specific time points, and in that way also be able to just understand it easier. Yeah, that's the idea, that you see these nice pictures and can easily understand what is done, and then you go to find the associated data to that. The problem then came up that we had this nice idea of this tool, but that printing these instances is quite time consuming. Yeah, if you do this in PowerPoint or something like that, they are becoming quite complex, and therefore we started this idea of creating a simple tool for that, which is more or less drag and drop. Yeah, you have to help me if you now see my other this other picture. This is the current prototype, yeah, where you can really easy create a new instance, and then instance map, and then you just drag and drop these things in there. Yeah, and you can connect them. You can have here these properties. You just drag there, and then you can get also here these. Give them a name. It's really very basic at the moment, but we are trying to understand how these things will be used, and then or improve on that. But it is already working to really go in there and have quite complex settings. This is again a nanophase area where you can really now scroll in, go there, look, for example, on the different test environments, also being able to describe what is actually needed to prepare these test environments, yeah, the biological environmental settings more. And you also see that there are quite some other things now getting in to make that a little bit more useful. That you say, okay, we have here the direct links to the protocols, or at least nodes at the moment for the protocols, that you can then at the end hopefully then directly assign the data also to it, and the metadata. Yeah, really having a link here to the protocols which are in there. Quickly going back to the presentation. Yeah, this is just the same, what I just showed, that these have a very limited amount of properties, but you can now follow these thing. Yeah, when you're starting material, then you don't do something with the starting material to then go get to the graphene oxide, for example, as another example, not from nanophase, but just being able to present that. And with these description, you could already start to put information in there on what you actually did, but this is clearly something we want to improve at the end. Following that, it became quite easy to understand that we could even do much more. And this is just a couple of things we are at the moment planning or testing. Yeah, I already mentioned that we could not only look at the particle, the nanomaterials, but also put more of the information on the test environments in there, and especially if you have relatively complex in vitro systems, that you have the chance to also describe how that has to been set up. You could go into calibration controls and calibrations, that these come in as a part, that you understand what, or also see how the quality of these is controlled and so on. You could even go into very much detail of the experiments that you have here, the raw data and the processing steps and so on. And what we are still struggling a little bit is this: how can we, for example, introduce here high throughput screening methods where you have a lot of parameters in these, which you actually would like to see in the instance maps. Yeah, this is just a first idea on having this kind of matrices in there, that you say, okay, you measure that over multiple days and different nanoparticles with different concentrations. But all these things are now possible. Martin mentioned already that we have these Friday meetings, and this is exactly where we try to understand better what is actually needed, what you would like to see, how would these be used. The first usage will be clearly that we have these maps and associate or have them inside the knowledge warehouse, and you get some kind, or when people are producing these maps, you will be able to see these maps in the knowledge base, and in that way have this visual view on this data set which you are looking at. Yeah, this is just, as I said, there is much more to it. especially also of thinking behind how that is coupled then with electronic lab notebooks or data warehouses and so on, that this is becoming more a tool in this whole universe of data management. If you are interested, please just contact me and I can invite you also to these meetings. That's all. Back to
yes, for contacting, please send message to either Thomas Exner directly or use the info@nanocommons.eu help desk that we provide. You find the email address in the NanoCommons knowledge internet page.
And also in the NanoCommons knowledge base.
Okay, so I'm actually going to pause the recording now because we're going to do some breakout rooms.
Good. So I hope you could clarify a number of questions in the breakout sessions. There was not too much business though on the protein corona modeling, but I guess there was quite some activity in the other breakout sessions. Maybe a few words from your side, Lee. You're muted.
Thanks. Yep. Yeah. Thanks, Martin. Yeah. I mean, it was just it was actually quite an in-depth discussion on from questions from Ralph with regard to sort of being able to get the data as a whole in order to then look for opportunities for mapping across to other tools. The one he mentioned was the Guide Nano tool, and also questions around sort of identification of particles around, particularly for ones that have gone under transformations, and so then they don't have their original sort of particle identities, and so how we assign that, and we were talking about using NinChi approaches there to then further help to identify those transformation products. Yeah, that was what the discussion.
I guess maybe NinChi is a good word, because I know that this was also talked about it by Dieter's workshop or Dieter breakout session, wasn't it?
Yeah, I briefly showed that we also have the NinChi calculator connected as one of the analysis tools in the NanoCommons knowledge base. So if you have a new nanomaterial that you want to add data about, you could try to calculate a NinChi, and that would certainly be helpful. And the discussion actually started by the question whether nanoforms will have overlapping data sets or redundant data sets in different data warehouses. And I'm quite sure they will, because I know that, for example, Maier has been producing FUSCAM characterizations for different aliquots of the same production batch, for example, aged particles and so on. So this is definitely the same nanoform as defined, and then you have multiple data sets for that. And the NinChi would be very helpful to find those together. And maybe briefly, the other question we discussed is how much effort it is to upload data. And the issue is that actually the upload itself is not a lot of action, because it can be done batch-wise if it fits into the template. But bringing the data into the template, that can be quite some effort. And if we have to come up with a new template like we had for nanophase, because it's complex data, then that also can take a bit of time on our side to map that template. What I realized during the discussion is we right now do not provide a batch upload for metadata, because so far that was very diverse. And therefore, that's a bit of an effort, because you upload for each of your data sets. That could be provided from our side quite easily if that's a requirement. So if you want to do batch upload of metadata, we could add that.
Good, thanks. I guess, Thomas, there was also a couple of discussions going on in your room?
Yeah, no, there was only one main question, and this is a nice follow-up to what Dieter just said, because there was a question if the NanoRec FISCAM templates would be supported, where I answered that in principle there are two options. Yeah, the one Dieter just mentioned, that existing there is a way to map existing templates to the data model in the NanoCommons data warehouse. The other option is using the established version of the eNanoMapper database for uploading these, yeah, and then use this linking of data mechanism to get it into the NanoCommons warehouse, or into this one search engine. And I think that is clearly something we want to stress here as well, is that there are the two ways. New data, yes, happily in we help to get that, but old data will come in there through the linking mechanism, and not by uploading the files again into this different data warehouse. No
Okay,
questions
thank you.
on the instance maps, but that might come.
I will address this single question which I just saw in the chat. Just very short. I mean, the access to the corona modeling is actually provided through the NanoCommons knowledge base. So you go in there, and the landing page are these kind of 4 squares here. And here in the analysis, the second one, you type corona analysis, and here you go. You can start with protein, nanomaterial, and the settings and stuff like that. Let me finish by some provisions on next week. So we are going to have 2 afternoons on semantic annotation, run by the team from Egon Billighagen from the University of Maastricht, Netherlands. We are going to have in the new year more on electronic laboratory notebooks to automatically by instant maps using import into the knowledge base, then also, and how to set up such systems, even by another hands-on afternoon session. And as we were just hearing today also from Thomas, our Friday meeting. So if you want to participate there actively, interact with us, build your own mind maps or your instant maps of your experiments into such kind of systems. We do this in a cooperative manner and try to use this if you are interested in that. It's a very interesting interaction there. Address this, kind of ask for the access code. We send you the link next Friday, I guess, or the next Friday is the next session. Good. With this, I would like to close and say thanks for everybody for joining, for approaching us. And of course, we are still hanging a bit in here. If you want to ask further questions, we are here. I guess we stop recording now. Have a nice afternoon and or still a good day if you are dialing in from the US.